Important equations in metallurgy chapter 7, revision equations as per 2023 syllabus, class 10 ICSE. So you can see the metals here: aluminium, zinc, Fe. Main ores: bauxite. What is the formula of bauxite? Al2O3 dot 2H2O. Aluminium oxide dihydrate. Cryolite. What is the formula? Na3Al F6. Corundum is nothing but anhydrous aluminium oxide. So that is alumina itself, Al2O3. Done. Come to zinc. Zinc blend. Zinc blend is nothing but ZnS. That is zinc sulfide. Zinc oxide is called as zincite. Okay. Calamine is zinc carbonate. Zincite is zinc oxide, ZnO. Come to ion. Red hematite. That is Fe2O3. This is ferric oxide, anhydrous ferric oxide. If it is hydrated ferric oxide, Fe2O3.2H2O, then it is called as brown hematite. If it is mixed oxides like Fe3O4, this is FeO plus Fe2O3, you will get Fe3O4. This is called as triferric tetroxide. Okay, iron pyrites, FeS2. See, it is FeS2, not FeS. Siderite is ferrous carbonate, FeCO3. Next, in 2023 exam, you have only extraction of aluminium. There are three important equations in concentration of bauxite ore by Bayer's process. What is Bayer's process? Conversion of impure bauxite ore to pure alumina. Alumina is Al2O3. So conversion of bauxite to sodium aluminate. First you will take bauxite. What is bauxite? Al2O3 dot 2H2O. To this you will add sodium hydroxide solution. You will get sodium aluminate, NaAlO2 plus water. Sodium aluminate is soluble in water. Okay, in this what happens? Impurities will be there, so those impurities will be removed by filtration. Okay, that impurities are called as red mud. Next, you will take sodium aluminate, add excess of water to this, excess of water. Next step, what is that? Conversion of sodium aluminate to aluminium hydroxide. You will get aluminium hydroxide insoluble in water, so it will form a white precipitate. You will get back the sodium hydroxide. Whatever initially it was used, it is formed back. You can use it once again. You can do the filtration, you will get the solid aluminium hydroxide. Next, aluminium hydroxide to pure alumina, you will simply heat it. And you will get alumina plus water. These are all not balanced equations. So what happens? They will ask you they will give you simply write how do you convert aluminium hydroxide to pure alumina. They will not give you anything. Okay, so you have to first remember this. Then you have to balance this. Temperature used for alumina bauxite to sodium aluminate is around 150 degrees Celsius. So if you balance this, you will get 2 NaOH and 2 NaAlO2 plus 3H2O. For second one, you need 50 degrees Celsius. Here 2H2O you need. That's it. For third one, heating, you need 1000 degrees Celsius and 2Al will give you 3H2O. Okay, so that's it. Hall-Heroult process, reduction of oxide. So after Bayer's process, we get alumina. So that will be reduced to metal aluminium by Hall-Heroult process. Electrolytic reduction of pure alumina is done in gas carbon lined steel tank. We use a steel tank which is lined with a gas carbon. So gas carbon here will be acting as the cathode. And what is the anode? Graphite. So both are inert electrodes. Now what are the electrolytes we are using? We are using cryolite, calcium fluoride, which is also known as fluorspar, CaF2, and alumina. The ratio between these is you take 1, 1 and 3. So 1:1:3. This mixture acts as an electrolyte. Now, very important, the reaction at the cathode and anode. See, alumina, when it forms ion, it will form Al plus 3 and what? O minus 2, right? So there are 2 Al and 3 O. So this is important. Now what happens? All the 3 oxygens will go to anode reaction. I will write first. So okay, the reaction at the anode will write first. Anion oxide will move. Every oxide will lose 2 electrons and form what? 1 oxygen atom. But how many 3 there are oxide? 3. So 3. So this will become what? 6 and forms how many? 3 oxygen atoms. But oxygen is not stable as atom, so you multiply this by 2. How many you will get? 2 into 3. 6 oxide ions will lose 2 into 6, 12 electrons, form 6 oxygen atoms. 6 oxygen atoms are nothing but 3O2, right? But what is at the anode? What is acting as anode? Graphite, and the temperature we are maintaining is around 950 degrees Celsius. So this oxygen will react with graphite. Graphite is carbon, reacts with oxygen, forms carbon dioxide. So these are the two reactions happening, 1 and 2. Because the graphite is consumed here, you have to keep on replacing the anode time to time. Then what about the reaction at the cathode? Very important. How many electrons are involved in the anodic reaction? Okay, same number of electrons must involve in the cathodic reaction. So here 12 electrons involved. So you will take aluminium plus 3, right? Every aluminium will take how many electrons? 3 electrons. But how many electrons? There should be 12. So if I write 12 electrons, we need 4 aluminium ions. 4 aluminium ions will accept 12 electrons and give you how many? 4 aluminium atoms. Okay, so this is the correct cathodic and anodic reaction. So where you collect aluminium, it's collected at the bottom of the tank because it is going at the cathode, which is a gas carbon line. So there will be a tap here. If you open it, you will get the liquid aluminium. Okay, so this is about the reactions of metallurgy. Thank you so much for your time.